Hello students, good morning to everyone. In our last 3 video, we studied about circles and the basic points, basic components relating to circles. We already discussed in our last 3 video. Also, we did 2 theorems relating to chord properties. Those 2 theorems are: if a line joining from the center to the midpoint of the chord is perpendicular to the chord. Our first theorem was a line joining from the center to the midpoint of the chord is perpendicular to the chord. And the next theorem was if a line drawn from the center to the chord is perpendicular to the chord, if a line from center to the chord is perpendicular to each other, then the line bisect the chord, means AM is equal to MB. These are the 2 theorems we already discussed in our last videos, but today we will go to next theorem. What is the next theorem? Now here another thing we also known here, these 2 theorems, the chord, if chord is smaller, it is far away from the center. If chord is larger, it is nearer to the center. So the smaller chord is larger distance from the center, and the larger chord makes smaller distance from the center. These are the 2 things to remember about 2 theorems. Next we will go to the next theorem. The next theorem, equal chords of a circle are equidistant from the center. Equal chords of a circle are equidistant from the center is our next theorem. Now theorem equal chords of a circle are equidistant from the center. This is theorem 3. Equal chords of a circle are equidistant from the center. This is very easy. The circle topic, all theorems are easy to understand, easy to work out. So now equal chords of a circle are equidistant from the center. Suppose this is a circle. Here is a chord AB, another chord. Suppose the center of the circle is O, another chord CD. So we have to prove these 2 chords, if AB is equal to CD, now given in a circle having center O, AB is equal to CD. AB is equal to CD. Equal chords of a circle AB chord is equal to CD chord have equal distance. We know the distance is the distance, altitude and perpendicular all are the same. So distance means perpendicular, altitude means perpendicular. So the distance means this is the perpendicular. Suppose OM and this is another perpendicular, that is ON. So OM is perpendicular to AB and ON is perpendicular to CD. Means OM is perpendicular to AB and ON is perpendicular to CD. This is the perpendicular. So as AB is equal to CD, so OM is equal to ON, we have to prove. To prove OM is equal to ON, means this is the distance, OM is equal to ON. Because as two chords are equal, they are equidistant from the center. So we take a circle with the center O and take two chords AB and CD which are equal. AB is equal to CD. Then the distance from AB to center O, that is OM is perpendicular to AB and ON is perpendicular to CD. Then we have to prove OM is equal to ON. Then construction. Now join OB and CD. Draw OB and CD. This much. Draw OB and CD. OB and CD. Now proof. Now look here. In triangle OMB, in triangle OND, these two triangles are a right angle triangle. First thing, this is the right angle triangle. This is right angle, this is right angle. So this is right angle triangle. Then another thing, OB is equal to OD. OB is equal to OD. Means the radius of the circle. One circle, all radius are equal. Now another thing, two congruent two triangles, minimum three components we should equal. We should do equal on both triangles. Then other three components must be equal after congruency. So we already proved, if OM is perpendicular to AB, a line is perpendicular to a chord, a line joining by a line from center to perpendicular to any chord, that line bisect the chord. So AM is equal to BM. As OM is perpendicular to AB, so AM is equal to BM. AM is equal to BM. Means BM is equal to half AB. BM is equal to half AB. Likewise, DN is equal to half CD. As DN is equal to half CD. Here AB is equal to CD. As AB is equal to CD, AB is equal to CD. So half AB is equal to half CD. implies that half AB, that is BM, is equal to half CD DN. So BM is equal to DN. Now take two triangles A OMB in triangle OMB and OND. In triangle OMB and OND, so angle OMB is equal to angle OND, that is equal to 90 degree given. Second, OB is equal to OD. OB is equal to OD, that is cos radius of a circle. Radius of a circle. And third thing, BM is equal to DN. Proved. BM is equal to DN. Proved. So triangle OBM congruence to the triangle OND, right angle hypotenuse side RHS. So two triangles are congruent to each other. The third side, the rest three components are equal, but we have need one component OM is equal to ON. So OM is equal to ON. Proved. OM is equal to ON because our statement is here, equal chords of a circle are equidistant. Equidistance means OM is equal to ON. When OM is equal to ON, at that time we understand that AB and CD are two chords which are equal distance from the center. So this is the statement, this is the proof. So this is the theorem 3. What about theorem 3? Our theorem 3, the statement was two chords of a circle, two equal chords of a circle are equidistant from the center. Then we draw a circle with center O and take two chords AB and CD which are equal. Then we do the distance. OM is perpendicular to AB, ON is perpendicular to CD. So this is the given point. Then to prove they are equal, means OM is equal to ON. Then we have a construction. Draw OB and OD. OB and OD. Then we take, as OM is perpendicular to AB, ON is perpendicular to CD, so AB is equal to CD, so half of AB is equal to half of CD. That is, in half of AB we can write BM or AM, but we have need the BM. So half of AB is equal to CD, so half AB is equal to half CD. So BM half AB means BM and half CD means DN. So we can write by the given point AB is equal to CD, so half AB is equal to half CD, so BM is equal to DN. Here is no need to write this thing, we can write here only this proper understanding as AB is equal to CD, so half AB is equal to half CD. AB is equal to CD given. So half AB is equal to half CD and BM is equal to DN. Half AB is equal to CD. Half of AB means OM is perpendicular to AD as OM is perpendicular to AB and ON is perpendicular to CD. So half AB is equal to half CD, BM is equal to DN. This much. Then we take two triangles, this angle and this angle 90 degree, and OB is equal to OD and BM is equal to DN. So two triangles are congruent to each other. So the rest part of the congruent triangles are also congruent. So OM is equal to ON, proved. This is the theorem. Take a screenshot. We will go to the next theorem. Theorem 4. Theorem 3, then theorem 4. Theorem 4 was reverse of theorem 3. Our theorem 3 was the equal chords of a circle are equidistant from the center. In reversely, we can tell the chords are equidistant from the center, also equal. Now just opposite. Chords comma equidistance from the center of a circle are also equal. Just opposite. Chords equidistance from the center of a circle are also equal. Now draw a diagram. Here is a chord AB, another chord CD, AB, CD. Here is O, OM is perpendicular to OM distance. The distance from O to AB is OM. The distance from O to CD is let ON because distance is perpendicular. So chords equidistance are same, means OM is equal to ON is our given point. But in our previous theorem, chords are equal. AB is equal to CD, but not here AB is equal to CD. Here OM is equal to ON. Then we can prove that AB is equal to CD. Now given in circle with center O, OM is perpendicular to AB and ON is perpendicular to CD and OM is equal to ON. AB is a chord, OM is perpendicular to AB and ON is a chord which is perpendicular to CD and OM is equal to N. To prove AB is equal to CD. AB chord is equal to CD chord. Then construction, same construction. Same construction, join BO and DO or draw BO and DO. This much. Now take two triangle. We have to prove OM is equal to ON. We know OM. Yes, take a two triangle. In triangle proof. In OMB triangle and OND triangle, we know OM is equal to ON, and this angle is equal to this angle, and this side is equal to OB is equal to OD. So these two triangles are congruent to each other by our given point. So in triangle OMB and triangle OND, OMB and OND, OM is equal to ON given. Second point, OMB angle is equal to OND, that is equal to 90 degree. It is also given. Third point, OB is equal to OD, radius of same circle, radius of a same circle. So right angle side hypotenuse, right angle side hypotenuse. So the triangle OMB is equal to, congruence to the triangle OND. So two triangles are congruent to each other. Two triangles are congruent to each other. So in congruent triangles, the rest components are equal according to CPCT. So BM is equal to DN. BM is equal to DN. If BM is equal to DN and ON is perpendicular to CD, we know the line drawn to the chord, when it will be perpendicular, so it bisect the chord. So DN is equal to BM. So double of BM is equal to double of DN, as OM is perpendicular to AB and ON is perpendicular to CD. So double of BM is AB, double of DN is equal to CD, proved. This was the proof of fourth theorem. Now take a screenshot. So two theorems we discussed relating to chord properties. Then another theorem we will discuss the next video. For today, this much. Goodbye. Thanks.